Good morning, Mom. Can you please just leave me alone? I'm already having a bad day.
Why? What's going on?
I just don't understand hyperbolas, and I'm trying so hard, but nobody is as passionate about hyperbolas as I am. I just don't get it.
One day a person who cares about hyperbolas will come into your life. For now, though, just keep trying.
Thanks, Mom.
Have a good day.
You too. Where am I? Who are you?
Shh, don't worry about it. I'm here to teach you all about hyperbolas.
My mom always told me not to talk to strangers.
Don't worry, I'm not a stranger. I'm Meredith the mathematician.
Okay, if you say so.
You finally met someone who loves hyperbolas just as much as you. Welcome to hyperbola class. The first thing you should know about hyperbolas is there are two standard forms. One, where the x minus h squared is over the a squared, and that is when the graph will be going horizontally. And the second one is when the y minus k squared is over the a squared, and that is when the graph will be going vertically. And the thing to remember is that the a squared will always be over the positive fraction, which is the first fraction. So, for the foci, centers, and vertices, the center will always be in the middle, and then from the middle to a vertice is A. And then from the middle to a foci is C. And the B line, which is the conjugate line, is always imaginary. And the transverse axis will always be crossing the points. And then see that on the vertical graph, the transverse axis goes through the vertices, the center, and the foci, and the conjugate axis goes horizontally. And if you don't have all of the components, always know that a squared plus b squared equals c squared. Never minus, always plus.
Okay, well, that makes sense, but how do I know the difference between the transverse and conjugate axis equations?
So, the transverse axis length will always be 2a. And when it is a horizontal equation, the y will equal k, and the k comes from the center. But when it is a vertical equation, the transverse axis equation will be x equals h, which also comes from the center. And for conjugate axis, its length is 2b. So for horizontal, x will equal h, which comes from the center, and then for vertical, y will equal k, which comes from the center. And lastly, the asymptotes. When it's horizontal, the only thing that's different is it will be b over a. When it's vertical, it will be a over b. And know that these points, y minus k, k is coming from the center, and then x minus h, h is coming from the center. So, do you think you're ready to try one on your own now?
I think so. So for the center, you see the x, the h is 0, and the k is 0 for the y. So the center would be 0, 0. The vertices, so we know the vertices comes from the variable a. So a, this is a squared, so a would equal 4. So you know, if the center is 0, 0, you don't have to do much work. You just subtract it from here. -4, 0, and 4, 0. Because it's horizontal, so it moves this way. The foci would be, so we know a and b, so we need to do the equation. A squared plus b squared equals c squared, always plus. So this is 16 plus 9 equals c squared, which we know this is 25. Take the square root, that equals c, which we know equals 5. So the foci is also on the same axis as the vertices. So this would be -5, 0, and 5, 0. Okay, now for the asymptotes. Y minus k equals plus or minus b over a times x minus h for the horizontal equation. So this would be y minus 0 equals plus or minus 3 over 4 times x minus 0. Okay, now for the transverse axis equation. Then for the transverse axis, remember, the equation is y equals when it's a horizontal hyperbola. And you would think it would be x equals, but it's not. It's going this way, which is technically on going through the y-axis in one point. Okay, the y would equal 0 then, because it equals k. And then on the conjugate axis, it's x equals when it's horizontal. And that equals 0 also because the center is 0, 0. Now lastly, for the eccentricity, remember that equation is c over a, which is 5 over 4.
Okay, and now that you learned everything, it's time for me to go.
Oh, that was a weird dream.